Forces and their effects.
Forces and their effects. You cannot see a force, but you can see what it does. You can also feel the effect of a force on your body. A force is a push or a pull. What can a force do? A force can make an object move. A force can make a moving object stop. A force can change the speed of a moving object. A force can accelerate an object. The larger the force on the object, the greater the acceleration if the mass stays constant. The larger the mass of the object, the smaller the acceleration if the force stays constant. Newton's second law of motion, force, N, equals mass, kg, x acceleration, m/s2. A force can change the direction of a moving object. A force can change the shape of an object. How to measure a force? A force can be measured with a Newton spring balance. The SI unit for measuring force is the Newton, symbol N. There are two main types of forces, contact forces and non-contact forces. A contact force occurs when the object or material exerting the force touches the object or material on which the force acts. A non-contact force occurs when the objects or materials do not touch each other. Contact forces. Impact force. When a moving object collides with a stationary object, an impact force is exerted by one object on the other. Strain force. When some materials are squashed, stretched, twisted, or bent, they exert a force which acts in the opposite direction to the force acting on them. These materials are called elastic materials, and the force they exert when they are deformed is called a strain force. Impact force. When a moving object collides with a stationary object, an impact force is exerted by one object on the other. Strain force. When some materials are squashed, stretched, twisted, or bent, they exert a force which acts in the opposite direction to the force acting on them. These materials are called elastic materials, and the force they exert when they are deformed is called a strain force. When the force applied to the material is removed, the strain force exerted by the material restores the deformed material to its original shape. Tension. Tension is a strain force that is exerted by a stretched spring, rope, or string. At each end, the tension force acts in the opposite direction to the pulling force. Non-contact forces. They all exert their force without having to touch the object. Magnetic forces, electrostatic forces, gravitational forces. Magnetic force. A magnet has a north-seeking pole and a south-seeking pole, known as North Pole and South Pole. If you pick up two magnets and bring them together, you will feel a force either pushing or pulling each other. The same poles attract each other while different poles repel each other. Magnetic force. A magnet can also exert a non-contact force on objects made of iron, steel, cobalt, or nickel. Either pole of the magnet exerts a pulling force on these magnetic materials. The strength of the force increases as the magnet and the magnetic material are brought closer together. Maglev, magnetic levitation, train. Maglev, magnetic levitation, train. Electrostatic force. If certain electrical insulator materials are rubbed and electrostatic charges, positive charge and negative charge, develop on them. Similar charges repel each other while opposite charges attract each other. Gravitational force. The force that exists between any two masses because of their mass is called the gravitational force. F is the force between the masses, G is the gravitational constant, which is approximately equal to 6.674 times 1011 nm2 kg2, m1 is the first mass, m2 is the second mass, and r is the distance between the masses. Gravitational force. The gravitational force between the Sun and all the planets in the solar system holds the planets in their orbits. The gravitational force between an object on the Earth and the Earth itself pulls the object down towards the center of the Earth and is called the weight of the object. Robert Hooke. The extension of a spring is proportional to the mass attached to it. F equals kx. F equals applied force, n, x equals extension, m, k equals force constant for object under test, n/m. However, the addition of mass to a spring beyond a limit, called the elastic limit, it no longer extends proportionally to the mass anymore. It is permanently deformed. The spring beyond its elastic limit was in a state known as plastic deformation. A spring balance. This instrument uses Robert Hooke's discovery. The scale on the balance is calibrated in Newton, so it is sometimes called a Newton spring balance or a Newton meter. Five N